Before moving to the next section on graphing equations, let's review what is slope.
Now, slopes measures the steepness of a line. It also tells us from left to right if the line is going to rise or fall. Now, slope can also be thought as a vertical and horizontal distance we must move from one point on the line to get to the next. We call this vertical distance the rise and the horizontal distance the run. Then the slope of a line can be found as a ratio of rise over run. We use the variable m to represent the slope. Then m will equal rise over run. If we are given 2 points, say x1, y1, and x2, y2, then the slope of the line will become the rise, the difference of the y values, and the run, the difference of the x values. Let's see if we can find the slope of a graph. In the first two examples, we're going to use the graphs of the last two examples of the video on plotting points to find their slope. So we begin by finding 2 points on the graph. To make the process easier, we will use points that are whole numbers. We don't want to guess with any decimals. So the way that we find points that are whole numbers, we're going to take those that are right at the corner. For example, I'm going to select 1, 4. It's on the line right at the corner. And then I'm going to select this one up here. I'm going to select 2, 9. Once I do that, I'm going to read these points from left to right. I need to know how much we need to move up or down and to the side to go from the point on the left side to the point on the right side. So let's start counting. From the left side to the right side, I will have to move 1, 2, 3, 4, 5 up. So that becomes the rise. And then 1 to the side. So that becomes the run. So if I try to find the slope, which is rise over run, that will become 5 over 1. But 5 over 1 is 5 divided by 1, which is just 5. That means that the slope of this particular line is 5. Now, you don't have to select the points that I did. You can select any points that you want. For example, if I had selected, let's say, one from down here at -1, -6, and then I selected that 1, 4 again. Then for this one, I will have to move 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units up and 1, 2 units to the side. But if we try the slope again, which is rise over run, this would become 10 on the rise and 2 on the run, which simplifies back to 5 because 10 divided by 2 is still 5. So it doesn't matter which points you select. If you move from left to right, you're going to find that the slope of this line is 5. Let's try another example. Now the points can also be selected from the x and the y-axis. They don't have to be selected from the quadrants like we did before. We still read from left to right. Here's a point on the left, and here's a point on the right. This time, instead of going up, I'm going to have to move down 4 units down. So then the rise will be -4 because I moved down. And then 1, 2, 3, 4, 5, 6, 7, 8 to the side. So since I moved to the right, that becomes a +8. I create the ratio, rise over run. So this becomes -4 over 8. Now 4 cannot be divided by 8 evenly, but it can be simplified. Both of these can be simplified by 4. So I end up with -1 over 2. Then the slope of this line will be -1 over 2. Now notice how in the previous example, the slope was positive and the line rose from left to right. And in this example, the line falls from left to right and the slope is negative. Let's try two more examples to see how they differ from these. Remember, we begin by finding 2 points. I'm going to select one on the x-axis and one on a quadrant. Let's select this one up here. Okay, so this is a point 3, 0, and this is a point 3, 4. All right, so let's bring down the formula. Remember, the formula was rise over run. And this time we don't have a left and a right. We have one on top of the other. So then we're going to go from the bottom to the top. The rise, I'm going to have to go 1, 2, 3, 4 units up. Okay. But that places us right at the point. There's no need for us to move left or right. That means that the run is going to be 0. But what happens when you divide by 0 is that you get an undefined value. That means that the slope of this vertical line is undefined because we end up with a 0 in the denominator. Let's try the next one. Let's try the horizontal line. First, we select 2 points. I'm going to select this one in quadrant 3 and this one in quadrant 4. Now I do have a left and a right. This point is -2, -4. And this one here is +1, -4. Let's bring the formula. The formula, remember, is rise over run. And let's see what that gives us. So going from left to right, I don't have to go up or down to get to the next point. That means that the rise is going to be 0. And the run is going to be 1, 2, and 3. So 0 divided by 3 is going to be 0. So when you have a 0 in the numerator, you're going to have a slope of 0. When you have a 0 in the denominator, you're going to have an undefined slope. Or you can think of it this way. As soon as you see a vertical line, you don't have to go and try to find the slope. Any vertical line is always going to have an undefined slope. And if you see a horizontal line, then you'll know that the slope is going to be 0 because all horizontal lines will have a run but will never have a rise. That's why the slope is 0. And in a vertical line, you will always have a rise but never a run. That's why the slope is going to be undefined. So let's do a summary here of the 4 different types of slopes that we saw in these examples. Okay, so you're always going to have a positive slope if your graph rises from left to right, like this one. From left to right is going up. You're going to have a negative slope if your graph falls from left to right. This graph is going down as you move from the left to the right. If you have a vertical line, you're going to have an undefined slope. Now, if you're looking at books on these, some books call this a no slope. And if you have a horizontal line, then you're always going to have a 0 slope.
Thank you so much for watching, and I'll see you in the next one.